Good morning, everyone. Welcome to another exciting episode of Dave Does Math from Home. Today we're starting section 4.3. This is the section on properties of logarithms. But first, we're going to talk about properties of exponents. So a little review. There are three really important properties of exponents that we need to cover. First one is about what happens when two exponential expressions are multiplied together. If they have the same base, you can add these things. You get a to the fifth. Something similar happens with division here. If you have a to the 7th divided by a to the 4th, you can turn that into a subtraction gig. And then the third one's a little different. If you have a, let's say to the 8th, and that's raised to another exponent, let's say 5th, then you can multiply them. So, these are the three important properties of exponents we're going to talk about. They are related to properties of logarithms that we're going to discuss, very closely related. And before I start to move to the properties of logarithms, I'm going to give these things names. The name that I want to use for this one is, for exponents, multiplication outside is addition inside. Multiplication outside of the exponent is addition inside of the exponent. That's what this means. This one's going to be a very similar name. No, that's in one. Oof. My mind is elsewhere. Division outside is the same as subtraction inside. And this one, I'm going to call exponents outside is the same as multiplication inside. This inside-outside distinction is very important. It's not enough to just sort of associate division with subtraction or multiplication with addition, because the position of these things matters a lot. If you just associate multiplication with addition, then you're going to get these two things mixed up a lot, because this is multiplication and this is multiplication, and one of them turns into exponents and the other one turns into addition. So you have to be very careful about where these things are. And I've tried to simplify these names as much as possible while keeping them accurate. So the operation and the position are what really matter here. You can transform these things into a different operation in a different position. But you got to be careful where it is. If the multiplication is outside, it's very different than if the multiplication is inside. So these are the properties of exponents that I want us to keep in mind as we start talking about properties of logarithms. So let's talk about, let's do the log base 3 of 81 times 243. So the thing about this problem is I don't own a calculator, and I have no idea what 81 times 243 is. I'm not going to do it by hand to figure that out, because if I do, I'm sure I'll just get some other huge number, and I don't know what the log base 3 of that other huge number is. So performing this multiplication is not going to help me. Here's what I do know about these numbers. I know that 81 is 3 to the 4th, and I knew that 243 is 3 to the 5th. So, my first step when doing a problem like this is to rewrite these numbers as powers of this base. Once I have it looking like this, I can use those properties of exponents we just talked about. I can change this into the log base 3 of 3 to the 9th. And since log base 3 of something means what exponent can I put on top of 3 to get this, I think it should be pretty clear at this point that the answer to this question should be 9. The exponent you put on top of 3 to get 3 to the 9th is 9. So, this is a real quick way to handle a problem like this. And the interesting thing about this number 9 is that's 4 plus 5. If I tried to do this separately, the log base 3 of 81 is 4, and the log base 3 of 243 is 5. If I want to handle these separately, I just need to add them to get the result I want. If I generalize this, it would look like the log base b of x times y is the log base b of x plus the log base b of y. So this is the first property of exponents we're going to talk about. And you may think that looks a lot like the first property of exponents we talked about. It's very similar. The first property of exponents we talked about was that multiplication outside could be rewritten as addition inside, and vice versa. I should mention that all those properties go both directions. Addition inside can be rewritten as multiplication outside. All of these are bidirectional. This is sort of the opposite. Here we have multiplication inside. And that's the same, again, bidirectional. This is the same as addition outside. So we have multiplication inside of a log is the same as addition between two logs. So you can split up this x times y into two different pieces. But the operation between them needs to become addition. It doesn't stay multiplication. So, this is our first property of logs. I guess I should highlight both of these things. This is the symbolic version, this is the words version. They are both the first property of logs, and they are very important, but now I'm erasing it so I can talk about the second one. Alright, second one we'll talk about, let's do something like log base 2 of 256 divided by 32. Again, I don't know offhand what 256 divided by 32 is. That's just not something I can do in my head. It's not something I want to do by hand. I'm going to start this one the same way I started the other one. I'm going to transform both of these things into powers of 2. 256 is 2 to the 8th, 32 is 2 to the 5th. Once again, I can use properties of exponents here. Division between exponents is the same as subtraction inside the exponent, so I'll call that 2 cubed. And I think it should be pretty straightforward that this is just 3. Once again, we have this property that if I did these things separately, this would give me 8. This would give me 5. And I can arrive at this correct answer by subtracting those two numbers. So again, if I do these separately, I can subtract the outcomes to get the correct answer. As a property of logs, that one looks like, actually, you know what? I'm not going to use this division symbol. I'm going to use a fraction bar. The log base b of x over y, because this is what your homework's going to look like, is the log base b of x minus the log base b of y. And in words, I'm going to call that division inside the same as subtraction outside. There is a third property of exponents that corresponds to the third property, there's a third property of logs that corresponds to the third property of exponents that we talked about before. But before we get into the third one, I want to pause and talk about these first two for just a moment. About 8 minutes or so ago, I said that the position of these operations was very important. That when I was talking about properties of exponents, because we have one property of exponents that does things with multiplication inside and one that does a different thing with multiplication outside. So you have to be very careful about where these things are positioned. If we're dealing with properties of logarithms, that is extra true. Especially because the properties of logarithms are all sort of backwards from the properties of exponents. A property of exponents was that multiplication outside became addition inside. And a property of logarithms was backwards. Multiplication inside became addition outside. So write these things down very carefully. Put a little, I don't know, bookmark in your notebook on the page where you write all these properties down so you can get it easily. It's really easy to get these things mixed up and confused, and I don't want you to do that. For example, the book might ask you a question like this. The log base 6 of 36x squared, right? And you might say, okay, well this is multiplication, so I can turn this into the log base 6 of 36 plus the log base 6 of x squared, and we know this is 2. 2 plus the log base 6 of x squared. This is excellent. This is good work. This is the kind of problem you'll see. This is using a property of logarithms to split it up into 2 pieces and then simplify it, and this is great. Here's what I don't want you to do. If you see something like the log base 3 of 9 plus 27, I'm worried that some of you are not paying attention to the position of these operations, and you're just sort of associating addition and multiplication, and you'll try to turn this into the log base 3 of 9 times the log base 3 of 27. This is not true. This is bad math. If I had multiplication inside, I could turn that into addition outside. The opposite isn't true. You can't turn addition inside into multiplication outside. It doesn't work like that. There is no property of logs to help you simplify addition inside. If you have addition inside of a log, that's it. You're done. There's nothing you can do. Leave it alone. I mean, simplified, I guess. 9 plus 27 is 36? Sure. Call it 36. But then don't try to, like, finish this. Don't do anything to that. It won't work. This is why you have to be very careful about the position of these operations. This one works because the multiplication is inside. This one doesn't work because the operation on the inside is addition, and there's nothing you can do with that. I'm going to cut this video here. We're going to talk about the third property of logarithms when I come back.